Okay, students, there are 4 questions. Okay, you can try. Okay, during this tutorial class. Okay, after the break, you can start. Okay, start to try to solve the questions. Okay, they are not difficult. Okay, I think if you try the questions during the class, you will be able to finish all the questions during the class. So later, I will come back to you to discuss the solutions after about half an hour. Okay, so I will give you a half an hour. I think you'll be able to finish it. Okay. Okay, the attendance form, after I update all of your attendance, I will give you the attendance form to fill up. Okay, students, you can start to fill out the attendance form. Okay, the link I have just shared to you. Students, I have checked that there are still 4 students haven't filled up the attendance form. Okay, please help to fill up the form now. Simpson and Leong Ho, Dear Leong Ho, uh, two of you haven't filled up the form. Simpson, not only, okay, so you forgot. Okay, if you can, you fill up now. Okay, so I received already now. Okay, thank you. Okay, shall I start to discuss the solutions with you? I give around half an hour. Okay, now I see that the time is already half an hour. Okay, I think I will discuss the solutions with you. Okay, for some of the questions, if you are able to find the answer, okay, you can post your answer in the chat box. Okay. Okay, let's have a look on question 1. Okay, this tutorial 5 is on dynamic power dissipations and static power dissipations. Okay, so the questions here all are about power dissipations. Okay, so question 1 is to determine the causes of dynamic power dissipations in CMOS circuit. Describe 4 techniques to reduce the dynamic power dissipations. Okay, so what is dynamic power dissipations, and what are the causes that cause this type of power dissipations? And can any one of you give me your answer? Okay, the answer is actually you can find from the lecture notes. Okay, no one want to share the answer? Okay, I will directly refer to the lecture notes. Okay, most of you can see. Okay, the question is about power dissipations. Okay, on this. Okay, there are two types. One is static power dissipations, another is dynamic power dissipations. Okay, so both of these power dissipations occur, okay, due to some reason. Okay, so question one is to ask about the cause of dynamic power dissipations. So these one are the cause. Okay, dynamic power dissipation is caused by the capacitive switching. Okay, sometimes we call it as power dissipations that caused by the switching, okay, or switching power dissipations. Okay, these dynamic power dissipations occurs when the circuit is on. Okay, when the circuit is on, and uh, the causes here, there are three causes. Okay, from the capacitive switching, gate linkage, and the short circuit. Okay, for static power dissipation, it is caused when the circuit is turned off. Okay, so you have to discuss these three causes. Okay, what is meant by the gate linkage and short circuit. Okay, and then the question also asks, okay, question also asks how to reduce the dynamic power consumptions. Okay, for this one, can I have someone to share the answer? What are the four techniques? Okay, I want to test your understandings. I actually prefer you to give me your answer. Okay, for some of the questions, I don't prefer to directly to give you the answer. I want to know how far you can understand. Okay. Thank you, Han Xiang. Okay, I see your answer. Okay, use lower VDD, use lower frequency, use suitable wire length, use suitable transistor size. Okay, your answer yes is correct. Okay, your answer is correct. Okay, so VDD is a supplies voltage. If you want to reduce the dynamic power dissipations, the VDD has to lower. Okay, this is correct. Frequency also. Okay, and suitable wire length and transistor size, both of these have to check. Okay, wire length also can be considered correct. Okay, this is correct. Just that transistor size, I'm not sure. Okay, so Yan Chen also give answer. Clock plating. Okay, with the sleeping mode. Yes, this is also correct. Okay, and also other answer like power efficient handling. Okay, this power efficient handling, this is another technique that we can also use to reduce the dynamic power dissipations. Okay, what is means by this power efficient handling techniques? You will have to read on this one. Okay, I'm not going to further elaborate on this. Okay, but most of you, okay, I see that the answer here are correct. Okay, if you answer with the questions given by Han Xiang and Yan Chan, okay, so means your answer is correct. Okay, now I goes to the next questions. Question 5. State the detrimental effects of power dissipations to modern digital system circuit in the CMOS technology. Discuss the importance of reducing the dissipated power in circuit. Okay, what are the negative effects of high power dissipations? Higher power dissipations will cause higher on-chip temperature and also reduce battery life. Okay, yes, this is correct. The importance of reducing the dissipated power include to increase battery life, to enhance noise margin, to reduce energy costs, to reduce use of natural resources, and to increase system durability. Yes, so all these are the answer for question 5. Okay. Okay, now I goes to question 6. Okay, consider the CMOS transistor in a circuit has an output with, okay, I think I should stop sharing the lecture slide. Okay, now is question 6. Okay, consider the CMOS transistor in a circuit has an output with load capacitance of CL equals to 120 femtofarad and supply voltage of 5 volt. Determines the allowable range of operating frequency if the circuit can sustain the power dissipations between 1.6 milliwatt to 2.04 milliwatt. Okay, what is the answer you get for this? 533.33 to 680 megahertz. Uh, okay, your answer is not the same with mine. How about others? Which formula are you using? Okay, I think for this one, I need to share screen to show my answer. Okay. Okay, we have to check together. Okay, maybe my answer is not correct. Okay, Han Xiang, okay, you mentioned that the formula you use is FCL VDD square. Okay, yeah. So the formula you mentioned is correct. Mine is wrong because here VDD is without square. So I suppose here should be square. Okay, if you use this formula, then I think your answer should be correct. That is the correct one. Okay, mine here is wrong. Okay. Okay, so all of you, when you try, please make sure you use the correct formula. Okay, if you use this formula, then you should be able to get the answer. Okay, so question 6, I think no problem. Okay, also easy, an easy questions. Okay, another questions. question 14. Okay, this question is to ask about the load capacitance. Okay, determines the load capacitance at the output node B of inverter X1 as shown in figure 2 below. Okay, this is the figure 2, okay, with two CMOS inverter. Okay, for this one, we have to draw the capacitance, okay, and to determine the load capacitance at the output node B. Okay, for this one, if you refer to the lecture notes, you should be able to figure out which and where to draw. Okay, again, I will show my answer here. Okay, you also can check. Okay, if my answer is not correct, you have to let me know. Okay, but this one I think should be correct, the correct one. Okay. Okay, the solution is this one. Okay, using back the figure 2, we can redraw it with the capacitance. Okay, the capacitance here including the drain and source to body capacitance. Okay, so at the node B, okay, this node B is connected to the drain. Okay, this is to the drain terminal. So at the drain terminals, there are junctions capacitance here for PMOS and NMOS. And also you see here, there is a wire capacitance and the gate capacitance, okay, of the second inverter. Okay, so if we want to determine the load capacitance, okay, that will include this. Okay, this is the output capacitance. This is wire capacitance and this is the gate capacitance. Okay, if we refer back to the lecture notes, you can easily compare. I think it's not this one. Okay. Um, okay, we should refer to this one, this slide, okay, for load capacitance. So load capacitance should include the output capacitance, okay, wire capacitance and input capacitance. Okay, so this one is consistent with the answer given in this. Okay. Okay, so I think that is all the discussions for the 4 questions. Okay, with the solution. Okay, other questions. If there is more time, okay, I will further discuss during the lecture class later. Okay, so I think there is no further questions, right? Okay, if no further questions, then we can dismiss class. Okay, no issue on your attendance. Okay, so I will see you on Wednesday. Thank you.